Greetings to all the viewers. The session is going to be conducted based on his heterocyclic compounds. We are in the series of heterocyclic compounds. In that regard, today's concept is about azitidine. Azitidine is the kind of a four-member ring system with the nitrogen as a heteroatom. It is the cyclic molecule with the four atoms containing one nitrogen heteroatom existing within the molecule. This is the session we are going to discuss about, and session is conducted by artificial intelligence and it is powered by AI. Let's enter into our today's session. Here, in this session, the concepts to be covered are intro regarding this azitidine molecule and how could be synthesized this molecule and what are the properties related with the azitidine molecule and what chemical reactivity accorded by the azitidine, and eventually application plethora regarding this azitidine molecule is going to be discussed. Introduction regarding this four-membered heterocyclic compound called azitidine is going to be discussed now. Four-membered heterocyclic compounds are the class of organic compounds characterized by four-member ring system. At least one heteroatom existing within the molecule, either nitrogen, oxygen, or sulfur atoms are the part of these four-membered heterocyclics. These compounds are strained due to the small ring size and making them reactive and useful intermediates in the organic synthesis. Right. So these are highly reactive in nature. That is because of a smaller ring size, and the ring strain is the common occurrence over there. If you're having a four-member saturated with the nitrogen heteroatom, that is designated as azitidine, and four-member heterocyclic with the saturated oxygen called oxetane, and a sulfur containing four-member ring system that is saturated one is called thietane, and four-member ring system with the two conjugated double bonds within the molecule called azide. Azitidine is the saturated, azide is the unsaturated, same four-membered ring system. And oxide for oxygen containing heterocyclic, and oxide may contain the double bond over there. So we need to insert a double bond over here. And thiide denotes what? A four-membered ring system with the sulfur heteroatom where one of the double bond existing within the molecule. This is the way nomenclature is provided. So the today's concept is regarding this azitidine molecule, where the synthetic plethora and the properties with respect to azitidine and the application domain of this azitidine are going to be discussed in the detailed manner. Let's enter into our today's concept, a four-member ring system with one heteroatom called azitidine. Azitidine is the cyclic ring with the four atoms over there. Three atoms are carbons only. Nitrogen is another heteroatom over there, and its molecular formula is mentioned as C3H7N. C3H7N is the molecular formula for this azitidine molecule. Basic in nature, being nitrogen atom with the lone pair of electron responsible for its basic nature, and it is also having tremendous applications in the field of medicinal chemistry. If you go with the azitidine, that is designated as C3H6NH. It can be reacted with any of the proton donating agent, here being water is amphoteric in nature, having provision to release the H plus ion, so that proton released from this water able to accepted by nitrogen and converted into a protonated one. So here azitinium salt formation is possible. In this manner, you can prove the nature of the nitrogen is basic. That is because of lone pair of electrons having provision to accept the proton, so that it is basic in nature. And here it's a basic ionization constant. Kb is designated, and that Kb is equal to the ions whichever generated by initial compound what we are taking, that ratio of the concentrations of these components taken as a base ionization constant. Let me show medicinal chemistry applications regarding this azitidine molecule. If you observe this, the blue color indication is given for this azitidine. Nucleus, here we have CFOTM, that is antibacterial in nature. This extent of larger one where we can notice azitidine, and also here sulfur moiety is present, here tetrazole nucleus is there, here thiazole nucleus is there. Though we are having these many heterocyclic compounds, here azitidine plays a role in antibacterial nature. And let me go with another compound where here cyclic lactam is there, that azitidine taken the skeleton over there, and it is substituted with the fluorobenzene, hydroxybenzene, and also here you can notice the another alkylated side chain with another benzene ring as well. This is the way ezetimibe, that is hyperlipidemic agent. So anti-hyperlipidemic agent, that is also lipids are nothing but fats. So in order to reduce the fat content, cholesterol content, here anti-lipidemic agents are taken into the part over there. And here is the molecule you can notice, that is azitidine, where it is in contact with the contact with the molecule where benzene ring is there, another 6-member ring with the nitrogen as an heteroatom, and here is the ketonic functional group. This is together regarded as antibacterial in nature. And another molecule whichever provided here will be a kind of pyrimidine molecule is there, that is in contact with this azitidine molecule. This is the N-ribosyl hydrolases and the phosphorolases. So it is the inhibitor. Whenever it is inhibiting ribosyl hydrolases and phosphorolases, that used to reduce or target the pathogenic organisms, right? So that genetic matter will be destroyed by means of this azitidine nucleus, so that it works like an antimicrobial agent. This is the way medicinal applications of this azitidine are taken into the consideration. Let me go with the synthesis of 4-member heterocyclic called azitidine. So azitidine synthesis is going to be discussed. The synthesis of azitidine and its derivatives involves a method that build a 4-member ring containing the nitrogen heteroatom, cyclization of 1,3-amino alcohols. 1,3-amino alcohols, 3-amino 1-propanol is the molecule taken. So whenever 3-amino 1-propanol is the starting material, it can be treated with sulfuric acid, or else a base catalyzed reaction. Acid or base catalyzed cyclization is provided over there, so that there is a formation of a final product as azitidine takes place. In order to achieve this reaction, nucleophilic substitution is carried over. Intermolecular nucleophilic substitution, where hydroxyl can be removed. That works like a leaving group along with the protonated product, so that water will be removed over there, and this nitrogen will nucleophilic nitrogen, because of lone pair of electrons, and the nitrogen will bind up with the carbon atom, giving rise to cyclization reaction. And it is purely mentioned over there, whenever you are taking this kind of hydroxy amino compound that is protonated under acidified conditions, whenever protonation carried here, you can notice oxonium ion. That oxonium ion easily removed simultaneously. Lone pair of electrons are going to cyclize with the carbon atom. Intramolecular nucleophilic substitution will be carried, so that you can notice azitinium cation that will be deprotonated, because initially we added H positive, so that here deprotonation will be carried, giving rise to azitidine as the final product. This is the way synthesis starting from hydroxyamines are possible. Now, cyclization of 1,3-dihalides with ammonia or amines. Whenever dihalide compound was taken, 1,3-dibromo compound, 1,3-dibromopropane was taken into this consideration, it can be treated with excessive quantity of ammonia. Heating or pressure conditions to be applied by molecular nucleophilic substitution, that is SN2 reaction will be continued. SN2 stands for what? Simultaneous addition, simultaneous departure. Making and breaking of the bonds within the single step is called SN2. That kind of intramolecular cyclization is proceeded in order to achieve azitidine as the final product. Let me show. the nitrogen, being it is Lewis base in nature, lone pair of electrons able to bind up with this carbon atom. Slowly this bromo group will be departed. Nucleophilic substitution we can denote it. And at the same time in either bromo is also removed by this hydrogen under heating conditions. So this ammonia should be added in the excessive quantity, so that HBr as the byproduct and giving azitidine as the expected product within the reaction. And the reduction of azitidinones. Reduction of azitidinones are nothing but we are taking ketonic functional group over there, which are called beta lactams. Hydrogenations of azitidinone to form azitidine is the reduction process. For this purpose, let me take azitidinone, a ketonic functional group nearby this nitrogen. This is the kind of cyclic lactam. And in the presence of palladium carbon, being it is a reducing agent, reduction is carried over and the entire carbonyl will be transformed into a carbon containing one, and this is called azitidine. So azitidinones will be transformed into azitidine by simple reduction. The reducing agent applied here will be palladium carbon. And this is the kind of another reduction, another synthetic plethora where you can observe. Don't fear about the entire slide where you are having much more examples, but only the thing I would like to present here is the iminium. So here is the double bonded nitrogen. Here is the double bond olefinic double bond. This double bonded nitrogen and olefinic double bond will proceed for 2+2 cycloadhesion reaction. This is photolytic condition. Under light conditions and under photochemical irradiation, double bond with another double bond will go with a 2+2 cycloadhesion reaction that is giving rise to a azitidine molecule. And being nitrogen is the part of this double bond, so that here is the azitidine nitrogen containing four-membered ring is originated, already existing heterocyclic remains as such, but in fusion with that one, here azitidine, new azitidine will be produced over there. And here again, let me take this same kind of molecule is taken, and another one is replaced. This olefinic double bond, now O benzylated allyl alcohol was taken into the consideration. At that instant, 2+2 cycloadhesion is proceeded, giving rise to a corresponding azitidine molecule. So all the reaction schemes whichever provided over here will giving rise to a 2+2 cycloadhesion among imine and olefin. Don't go with another kind of distractions. Rather, you can focus upon this imine and olefinic double bond will proceed for 2+2 cycloadhesion under photolytic conditions, giving rise to azitidine as the expected product. Further transformations are possible that requires further chemical reactions, but our requirement is regarding the synthesis of azitidine that will be proceeded within single step only. Here again, you can notice this imine, and here is the double bond with the bulkiest groups over two edges. And again, here the concept is 2+2 cycloadhesion. Photolytic conditions will be applied over there. And again, here azitidine will be generated, and this carbon atom is in having two alkyl side chains, so that extent bulkier groups containing azitidine molecule will be originated. Now let me show another mechanism for the synthesis. This is another strategy. Here I am taking this kind of indole nucleus. Indole nucleus was taken, and here is the reagent added will be hydrazine. Hydrazine having natural provision to form a condensation reaction with the ketone rather than this amide. Without disturbing this amide linkage, here ketone will participate in the condensation reaction, giving rise to hydrazone derivative. Later on, hydrazone derivative can be treated with this benzaldehyde will go for skip base formation. Benzaldehyde again, here NH2 free NH2 will condense with this aldehyde, giving rise to a skip base. The skip base is generated. So whatever skip base generated can be treated with this a kind of alpha chloro acetyl chloride. Alpha chloroacetyl chloride is the reagent added, and also triethylamine is the mild base applied over there. Basic conditions are required in order to go for the cyclization reaction. This imine again go for the reaction with this kind of reagent and giving rise to four-membered ring system where azitidine is the skeleton provided. So whatever starting material indole is there, that remains, but azitidine nucleus is originated upon this steep base. Let me go for the another. Just now we discussed about 2+2 cycloadhesion reaction. That cycloadhesion reactions involving imines. So the important one skeleton will be imine, another will be olefinic double bond, that is alkene. Starting materials required are imine and alkene. So both the reactants are required. The catalyst will be the reaction is initiated by photochemical condition, and even by heating thermal activation is also possible. Mechanism is concerted cycloadhesion reaction. It will be azitidine ring formation is possible, and that is highly strained one. Product will be substituted azitidine. Let me show the reaction. Here you can notice. Here is the imine moiety and olefinic double bond under H nu conditions, giving rise to a four-member ring system called azitidine. That is the way the azitidine molecule formation is possible. Let me show the same reaction over here. Alkene is one of the moiety, and imine is another moiety. Alkene combines with the imine by the process called 2+2 cycloadhesion. That is light irradiation photochemical conditions should be applied. And the product formed will be a functionalized azitidine formation is possible. This is the azitidine what we are expecting by the cycloadhesion reaction. And this reaction is designated as Azza-Paterno-Bucci reaction. Paterno-Bucci reaction is most common kind of reaction, can be operated in photochemistry. So exact pattern of Bucci, in the sense nitrogen is the part of the cyclization. That's the reason why you can mention the reaction as a pattern of Bucci reaction. And here is the four-member ring system origination from different pathways. You may take this three-membered ring system. Three-membered ring system will be there. That will be added with this compound. Whenever this sulfone compound is added here, double bond CH2 is there, that used to originate this carbene. Carbene will go for the ring enlargement of this three-membered ring system, giving rise to four-membered azitidine. And another pathway is regarding this five-membered ring system will go for ring contraction. In order to contract the ring, first of all, nucleophile should attach at this carbon atom, so that further ring opening reaction will be carried, and there is a provision to bind this carbon with the nitrogen directly, so that there is a formation. Ring contraction will be generated. Ring contraction will be possible by means of this five-membered ring system whenever reacted with the nucleophile. In another reaction, let me go for reduction process. And here is the ketone on this four-membered ring system. This ketone can be sufficiently converted into alkyl by Clemmensen reduction or else Wolff-Kishner reduction, so that ketone will be transformed into a kind of alkyl moiety. And here is the open chain molecule, where one edge we have a nitrogen and either edge we have a halogen, so that for exotertiary cyclization is possible. So nitrogen will proceed for the cyclization reaction with this carbon atom. Subsequent dehalogenation process is carried, giving rise to a kind of a four-member ring system. Let me go with the again three-member ring system with the nitrogen heteroatom. And Jamieson's coupling cyclization get carried over. Whenever Jamieson's coupling reaction is carried upon this molecule, here is the alkyl group present upon this, and that will go for the ring enlargement reaction. Whenever this alkyl group is present, that CH2 will inserted within the molecule, giving rise to four-member ring system. And these are the ways in order to achieve this four-member ring systems. These are some other typical synthetic strategies in order to synthesize this azitidine molecule. And this azitidine molecule having strong tendency to go for this lithium reaction with lithium so that the whatever alkyl is there can be substituted by lithium. So this lithium substituted compound is also possible. This is said to be organolithium compound, can find applications in the field of synthetic organic chemistry further. Now, let me show, just now we gone through this ring contraction reaction. How can we minimize the 5-membered ring system into a 4-membered one, and what is the mechanism behind that? And again, I'm taking same kind of molecule, that is a cyclic amide called lactam. Potassium carbonate is a strong base, excessive quantity, 3 equivalents will be added over. Methyl cyanide is the kind of solvent. This is called acetonitrile. And nucleophilic reagent will be added either ROH or else RNH2. Whenever these nucleophiles are added, nucleophile having strong tendency to bind up at this carbonylic carbonatum, subsequent ring opening reaction is possible, and this whenever ring opening is carried, this nitrogen, being it is electron pair containing species, will go for the ring cyclization with this next carbonatum, and this bromo will be subsided and giving rise to a 4-membered ring system. And wherever this C double bond O group, which is in addition with the nucleophile is there, that remains as the side chain. The nucleophile where it is added and the carbonylic carbonatum will remains as a side chain, and this R1, R2 groups remains on this 4-membered ring, and whatever this protecting group is there upon the nitrogen will remain as such. This is the way ring contraction reaction will be proceeded. And again, let me go with the 2+2 cycloaddition. One is olefin, another is what is this? Imine. These two get condensed by the catalytic addition reaction is also possible. This is called as catalytic cycloaddition reaction. Iridium complex will be taken into the consideration in acetonitride solvent. Blue LEDs will facilitate the reaction rather photochemical conditions. Here is the azitidine molecule formation. Now let me show another segment. Till now we gone through various synthetic routes for the azitidine manufacturing. Now we will discuss about the properties for this azitidine. Properties of azitidine. Azitidine is a 4-member ring system with 1 nitrogen heteroatom. The structure and properties important compound in the synthetic and medicinal chemistry. So even for the synthesis of a new kind of organic compounds, it is essential, and even in the medicinal chemistry as well, their impactful applications are available. Let me show. Molecular formula will be C3H7N. This is the molecular formula, 3 carbons, 1 nitrogen resided within the 4-member ring system. Molar mass will be 57.09 gram per mole. Appearance, azitidine is a colorless liquid. It is available. So this is kind of injections are available for the curation of the cancer in the chemotherapy. And odor, ammonia-like smell is available. It is a pungent liquid, and the odor will be ammonia-like smell is available. That is again because of what nitrogen existence. Again, it is the nitrogen containing compound, so that it smells like ammonia. Boiling point at 62 to 65, being it is a liquid compound, it will boil at 62 to 65 under atmospheric pressure conditions and melts at minus 43 degrees centigrade. If we go to the minus 43 degrees centigrade, melting of this azitidine is possible. Solubility. So being it is a polar compound, obviously solubility in water is available, and organic solvents also able to dissolve this compound because of the carbon content. And there is a provision to generate hydrogen bonding with this molecule. It able to generate the hydrogen bonding. Density will be 0.866. It is lesser denser than water. If you go with the nature of the compound in terms of chemical reactivity, let me say it is the basic compound. So why basic nature is important? Due to the existence of nitrogen, being it is a Lewis base, lone pair of electrons are recording for its basic nature, and it can conveniently reacted with the acids. Here perchloric acid will be added over this azitidine. Protonation is carried over the nitrogen, giving rise to azitinium cation. And the azitinium salt formation is possible instead. And that azitinium salt, whatever generated, can bind up with another azitidine molecule and giving rise to a kind of an alkylated product. Azitidine can be treated with hydrochloric acid, giving rise to azitidinium chloride salt, and its pKb value is indicated as 10.9. Higher the pKb value, lesser the basic nature will be, because it is nitrogen is existing in the ring system. That's the reason why lone pair of electrons are not that easily released to the acid, so that the basic nature is not that extent, right? So this is the way its basic nature is explained in well manner. Let me go with reactivity. So whenever you can observe the reactivity for this acetylene molecule, the reactivity is extremely larger, and that is purely because of ring strain. Being it is a four-member ring system and all the bonds are very concised in nature, the bond angle is indicated as 90 degrees. Actually, required expected to be 109 degrees, 5 minutes only, but it is concise to 90 degrees because of the ring strain. In order to relieve the ring strain, the molecule will participate in a kind of ring opening reaction in the faster manner. That's the reason why high reactivity will be accorded for these compounds. Ring strain for azitidine molecule is calculated as 25.2 kilocalories per mole. This extent of ring strain is available within the molecule. And it will go for the ring opening reactions by treating with the nucleophilic reagent. So let me treat with thioalcohol. Whenever thioalcohol is reacted with this azitidine molecule under catalytic conditions, that able to open the ring system. A nitrogen will be added with hydrogen, and remaining this thioalkyl group will be added to another edge of the carbon, giving rise to open chain molecule. And another entosyl acetidine was taken over there, and here this is a kind of reagent, alkyl trifluoroboron complex, that salt will be added, sorry, not the complex, salt will be added over there. Whenever this is the case, added upon this acetidine molecule, that will participate in the ring opening, and nitrogen edge added with hydrogen, and another carbon will be added with alkyl group, so that ring opening is carried over the nucleophilic substitution reaction. Let me go with this acetidine, which is having a side chain of a longer chain alkyl that will be treated as nucleophile, able to expand the ring system in such a manner. A ring system will be expanded and giving rise to polymeric compound of 5-member rings. Sorry, not 5-member, polymeric compound of the more number of alkyl groups over there. And this acetidine will go for ring expansion reactions in this manner, either for 5-member or else 7-member rings also possible. 8 members you can notice by means of pericyclic rearrangement reaction. Pericyclic rearrangement is occurred whenever suitable side chains are available within the molecule. And let me go with another ring opening reactions further. This intersilated acetidine is treated with benzene, and ytterbium catalyst was added over, and that able to open the ring, so that nitrogen will be binded with the hydrogen, and carbon chain will be attached to the alkyl group, so that ring opening reaction will be accorded. And here is another example. You can notice an alkylated chain will be there, that is added with this imine, a rhodium catalyst playing a role in order to facilitate the reaction. So this compound, iminium, is able to generate the carbene having obvious ring expansion reactions in general, so that 4-membered will be transformed into 5-membered ring system. And this is facilitated by the rhodium catalyst, whichever operating over there, and that directly bind into the nitrogen atom. Stepwise constructed mechanism will be followed. Ring opening is accompanied whenever ring opening carried, so that the next carbon atom with the negative charge will go to this carbon atom in order to expand the ring into the 5-member system. And here is the again acetidine treated with the trifluoroacetic acid, Whenever trifluoroacetic acid is operated upon this molecule, that will participate the side chain ester in substituted ester is there. That ester will participate in the ring expansion reaction, being it is highly strained one. So that within the molecule, this O minus will go after the cleavage of the ring and will generate the six-member ring system. Another example, HF is added in this molecule. Whenever HF is added, HF having tendency to bind up in order to cleave the azitidine ring system, and hydrogen attached to the nitrogen, and fluoro will go towards the carbon, giving rise to open chain molecule. And this is another example. It is not the kind of ring opening, rather it is the chemical reactivity only, right? So I'm taking a quinoline ring system, and here acetyl chloride is the active functional group responsible for the reactivity with azitidine. This acetyl chloride, whenever treated with this azitidine molecule in the presence of tetrabutylamine, this is a kind of quaternary tetrabutyl ammonium bromide. So this is phase transfer catalyst, and able to remove the hydrochloric acid, so that here the formation of azitidine is possible. And there is origination of four-member ring system over the quinoline and giving rise to a product. This is already published reaction in the year 2016. Simply azitidine will go on the substitution reaction on this acid chloride. Let me show hydrogen bonding about this azitidine molecule. Azitidine is polar in nature. Nitrogen lone pairs are available that having strong tendency to bind up with the hydrogens of the water molecule. At the same time, hydrogen present on the azitidine molecule also responsible for the hydrogen bonding with oxygen of the water molecule. This is the way hydrogen bonding is more prone in case of azitidine molecule. Polarity matters. Ring strain. So four-member ring systems are highly strained. A 90 degrees angle will responsible for that kind of strain within the molecule, and 25.2 kilocalories per mole is the calculated ring strain for this azitidine molecule. Thermal stability. Whenever we are heating to higher temperature, it will obviously go for the decomposition, and ring opening will be accompanied. Whenever ring opening is possible, some other kind of compounds are also generated. Here you can notice initial azitidine is there. Upon heating higher temperature, that able to expand the ring system in such a manner, and that azitidine molecule totally decomposed, and that will go to the another heterocyclic compound, and here is the formation of five-member ring system is possible. This is the thermal decomposition. The topic now we shifted into the applications of the four-membered heterocyclics, that is azitidine. Azitidine applications are going to be discussed. Medicinal chemistry applications about azitidine. Azitidine and its derivative serves as a building blocks in the drug design. Especially anti-cancer agents are available, antibacterial agents are also available, right? So here you can clearly observe the commercially available azitidine injection is there in order to curate that malignant tumors called the cancer. So it is the anti-cancer, better anti-cancer drug whichever available within the market. And these are the kind of molecules which we already discussed at the starting of the session. These are working like an antibacterial, anti-hyperlipidemic, and ribosyl, this is antimicrobial and antibacterial again. The molecules, all these larger molecules are accompanied by the azitidine nucleus within their core. Organic synthesis, so many kind of a larger extent, larger sized organic compounds can be manufactured starting from this azitidine molecule. So many chemical transformations are required to be done in order to achieve the greater the size of the molecule, so that so many complex heterocyclics can be manufactured starting from this azitidine molecule. So this is the way anti-malarial agent will be manufactured in this stepwise manner. And this is the another compound where you can notice the saturated heterocyclic with the two hetero atoms of the nitrogens can be treated with this azitidine nucleus, and that ring extension, that ring fusion is possible among two heterocyclics, and further reacting with the trifluoroacetic acid, giving rise to a huge molecule. Polyannular system will be originated. There you can notice the thiazole, and here it is the kind of piperidine, and here is the azitidine nucleus. Indole moiety is there, n benzylated n phenyl indole is there. This extent of larger molecule is also synthesized starting from this azitidine molecule. And let me show a polymer. They are also the part of polymers. They are able to generate the polymers, azitidines having tendency to polymerize themselves in such a manner. N number of such molecules will go for that kind of reaction, giving rise to the molecule of larger aminopolymers will be originated. 2200 the molecular weight containing polymers will be originated starting from these azitidine molecules. And here is the another polymerization reaction is recorded when an alkylated azitidine is taken into the consideration. And there is a reaction between this azitidine molecule. Quaternary azitidine was taken and treated with the triethylamine and giving rise to open chain molecule. That polymerization will be proceeded further, and this is published in the journal Polymeric Journal in the year 1980. This extent ancient work, it will be the polymerization of azitidine is very ancient in nature. By this, we successfully completed, and that is really a kind of informative session, and very what strainful information gathering was carried for this. And this will be very much helpful for the researchers who are working on the field of synthetic organic chemistry, in the field of heterocyclics especially, and also the therapeutic materials, those who are interested to synthesize in the field of pharmaceuticals and new drug auxiliary synthesis, and also photochemical conditions. All these fields will cover this azitidine as a core moiety. And the people who are in graduation and post graduation in the field of chemistry, well, the session is really helpful. And those who are preparing seriously about career opportunities in the field of chemistry, and also towards the competitive examinations and entrance examinations like state eligibility for teaching, national eligibility for teaching, CSIR, GRF, in all these kind of competitive exams and entrance examinations, the kind of session is very much helpful. The session conducted by Dr. Kavita Kottireddy Kota. I'm an academician and researcher, and this kind of much more information will be retrieved from the channel called World of Competitive Chemistry. By this, we are going to conclude the session. Let me sign off for the day. Thank you very much for your patient listening. Thank you, one and all.